So today we will be doing class 8 physics, and we will be continuing with what we have been doing last week, that is work and energy. So last time we did what work is, the definition of work, the factors on which work depends, and the numericals related to work. So today we will be discussing about energy. Okay, so the chapter is work and energy. Now, what is energy? When you wake up in the morning, what wakes you up? It's the energy that helps you to get up. So you see energy everywhere, isn't it? Energy is present everywhere. Right now I'm speaking, that is my sound energy. You do some work. So everything, whenever you do some work, what is related to it? Energy. That means to do a work, what do you need? Energy. Okay, so if you don't have energy, you feel lethargic, you just sit and do nothing. So to do any work, you need energy. Thus, energy and work are correlated. So, how do we define energy? Energy is the ability to do work. That means to do a work, you need energy. Okay, without energy, you cannot do work. Thus, energy is defined as the ability to do work. Okay, so energy makes change possible. Like when you are just sitting down, idle, not doing anything, and if you want to just get up and walk, so what do you need? Energy, isn't it? So what is helping you to do that work? To stand and then walk around? It is energy. So energy makes change possible. So how do we define energy in physics? Energy is the ability to do work. And since energy and work are correlated, they share the same units. That is, the unit of work is joule. We discussed that last time. So the SI unit of energy is also joule. Okay, represented with capital J. And there are other kinds of energy. There are different forms of energy. Okay, and we'll be discussing about those different forms of energy today. Now, different forms of energy. These are the different forms of energy here. And most of them, some of them might not be there in the book, but we can just discuss it for your knowledge. So the first energy that we have over here is mechanical energy. Okay, what is mechanical energy? Energy possessed by a body due to either in motion or at certain heights. Okay, so energy possessed by a body when the body is in motion or when the body is at a certain height, that energy is called mechanical energy. Thermal energy means heat energy. Okay, thermal means heat. So thermal energy is your heat energy. And what is heat energy? It is the form of energy which helps us, which gives us a sensation of hotness or coldness. Okay, nuclear energy. You know nuclear energy. There are elements which have very high atomic number and they have heavy nucleus. So and they are unstable. So when they want to become stable, they disintegrate. Okay, the nucleus, they split into different nuclei. And when they split into different nuclei is the plural of nucleus. That means many nucleus. Okay, so when they split into nuclei, what happens? They liberate energy, and that energy is your nuclear energy. You know the uses of nuclear energy. It's used in nuclear power plant, this one hydrogen bomb, isn't it? To make bombs and all. You know that very well. Chemical energy. Chemical energy is also called stored energy. Chemical energy is the energy which is present in the elements, okay, the fundamental particles of an atom. So when the elements combine to form a compound, or when they undergo any reaction, they liberate energy. Okay, to undergo some reaction, they need energy, isn't it? Because reaction is to do some work. So when they need to undergo some reaction, they liberate energy, and that energy is your chemical energy, which is present in the bond. Okay, when the electrons they move out of the orbit, they liberate that energy, and that is your chemical energy. The chemical energy is present in the cells, batteries. Okay, we'll be further discussing that later. The electromagnetic energy, which is related to the magnets. Okay, even they do need some energy, isn't it? When current passes, okay, before we discuss electromagnetic, let's discuss magnetic energy. When magnetic energy, when magnets, they attract particles around them, isn't it? The iron objects or the metals around them. So when they attract those metals around them, they're doing some work, okay? And what energy helps them to do that work? It is the magnetic energy. Now electromagnetic is when current is passing through a coil, okay, say this is if you have wound wire around it, and if current is passing through this, you place a magnet near it, what will happen? Or you place a iron needle near it, what will happen? It will be attracted. That means along with electricity, magnetism is also produced. Okay, so that is your electromagnetic energy. Now sonic energy. Sonic energy means the sound energy. So every time a sound is produced, it vibrates. Okay, sound is produced by the vibration of particles, and we'll be discussing that in other chapter. As of now, just understand that sound is produced by the vibration of particles. That means when an object vibrates, it is doing some work, isn't it? And that energy produced is sonic energy. Now gravitational energy, you know, everything that is thrown up is pulled down because of the gravitational force of the earth, isn't it? And that means the earth is also doing some work, okay, and the energy used in doing that work is gravitational energy. Kinetic energy. Now kinetic energy means when the body is in motion. If the body is moving, any object that is moving, okay, if any object that is moving has kinetic energy. For example, I am switching this, so it is in motion. What energy does it gain? Kinetic energy. A car moving has kinetic energy. Okay, any object that is in motion has kinetic energy. Another one is potential energy. Potential energy. Potential energy is the energy possessed when the body is at a certain height or due to its position. Okay, for example, I have this at a certain height. Now I've kept it over here. I lifted it up from the desk and it is over here. It is at a certain height, isn't it? From the ground. It's not at the ground, it's above the ground at a certain height. Now it's not moving, it's still. What energy does it gain? It gains potential energy. That means due to energy possessed due to the height or the position of an object. And ionization energy, which is related to ions. We don't need much of this. You know, when atoms lose electrons or gains electrons, they convert into ions, which you might have learned in chemistry. So we'll not be discussing this in detail. So these are the different forms of energy, and of all this, the important one that we'll be discussing in our class will be kinetic, potential, gravitational, sound, thermonuclear, chemical, mechanical and magnetic. Not electromagnetic but magnetic. So these are the different forms of energy, and some of the examples given there. You can see the picture there. Now actually, you know, the energy can be categorized into two types. Okay, and actually the energy, the entire energy can be, different forms of energy can be categorized into two types. One kinetic, the other potential. Now see here, types of energy, some of the examples, these are the examples, okay. So mechanical, you have living frog, moving car. Heat, for heat energy you have melting ice cream, heating soup. For electromagnetic you have the lights, okay, the bulb that glows. The infrared radiation, the radio waves, and the electrical you have power lines, lightning. Then chemical you have food people eat, striking a match. Then nuclear you have nuclear fusion, sun and stars. You have nuclear fission. Fusion means, okay, we'll get into that later. as of now, just see the examples, okay? Now, types of energy. So I told you they can be categorized into two types. One is kinetic and potential actually. So which are the energy which falls in kinetic? Mechanical energy, electrical energy, thermal energy, radiant energy, sound energy, potential, chemical, nuclear, gravitational and elastic. We don't need elastic energy, which is it is also a form of potential energy only, okay? So chemical energy can also be considered to be a form of potential energy. So you can see the examples here. So what is kinetic energy? Energy due to motion. What is mechanical energy? Due to motion and position. What is thermal energy? Energy due to heat. Radiant energy because of the light. Sound energy by the vibration of the particles. Potential energy is also a stored energy, and chemical energy is also a stored energy. Nuclear energy is also a form of stored energy. Gravitational energy is also another form of stored energy. Okay, so these are the different forms of energy. Now, starting with mechanical energy. What is mechanical energy? So I told you in the beginning that mechanical energy is the energy possessed by a body when in motion or either at a certain position, isn't it? So actually mechanical energy is a combination of potential and kinetic. So when you add up, sum up kinetic and potential together, they are together called mechanical energy. So energy due to the object's motion or position. Okay, motion means kinetic and position means potential. Now example here, the bowling ball. Okay, you see the bowling balls. So when the ball strikes the pin, mechanical energy is transferred to the pin. So when you strike when you move, when you throw the ball, what happens? It is in motion. This would be at potential energy, isn't it? So when you throw it, when the ball strikes this pins, what happens? They will all move. Okay, when they move, the potential energy is converted to kinetic energy. So it's a combination of potential and kinetic. Now, kinetic energy. Kinetic energy, as we discussed already, kinetic energy is the energy possessed by a body due to its motion. Okay, when the body is in motion. So any object that is moving, okay, any object which is in motion has kinetic energy. And the mathematical expression for kinetic energy is half mv square. M stands for mass, V stands for velocity, and Ke stands for, it's a short form of kinetic energy. So this expression is very important. We'll be doing numericals related to it. So please see this. Kinetic energy equals to half mv square. M stands for mass, V stands for velocity. Now, from the expression itself, we can make out that kinetic energy depends upon mass and velocity. So these are the two factors in which kinetic energy depends upon. One is mass, the other is velocity. Okay, velocity has the most effect. That means when you double the velocity, okay, more than mass, velocity has more effect on kinetic energy. That means if the velocity increases, that means if the speed increases, kinetic energy will also increase. Okay, and not just increase, but it will double. Okay, the kinetic energy will be doubled. Okay, so you know the formula already, we discussed that. Now, how does it depend upon mass? If more the mass, more will be the kinetic energy. So tell me, if you roll an apple and a watermelon, which has more mass? Watermelon, isn't it? So watermelon has more mass than apple. So when you roll them both together, which one will gain more kinetic energy? It is the watermelon, because watermelon has more mass. That means more the mass, more will be its kinetic energy. See here, there are two objects. One object which weighs 100 kg, the other object which weighs 50 kg. If you move them, if they move with the same speed or Okay, but their masses are different. So which one will have more kinetic energy? It will be the object which has more mass. That means more the mass, more will be the kinetic energy. The second factor the kinetic energy depends upon is velocity. That means I've already discussed, more the velocity, more will be the kinetic energy. So there are two objects which have the same mass. Okay, say the two objects having the same mass, 100 kg and 100 kg. If one object is moving with the speed of 50 meter per second and the other object is moving with the speed of 10 meter per second, which one will have more kinetic energy? Obviously, it is the object which is moving with the speed of 50 meter per second, because the velocity is more here. If the velocity is more, kinetic energy will also be more. So how does kinetic energy depends upon mass and velocity? Larger the mass, more the velocity, more the kinetic energy. Okay, and more the velocity, more will be the kinetic energy. That means kinetic energy is directly proportional to both mass and velocity. Now the second type of energy that we'll be discussing here is potential energy. And what is potential energy? The energy gained by a body due to a certain height or due to its position. Okay, so when the body gains energy because of its height or its position, then we call it as potential energy. Now some of the examples of potential energy. See here, when you play a slingshot, isn't it? When you stretch, when you are throwing using a slingshot, you need to pull it. You need to pull the rubber, isn't it? So when you pull the string, what happens? The energy that is used here is the potential energy, because its position has been changed, isn't it? The string was at rest. When you twist it, what happens? It changes its position. Okay, so what is the energy gained? Potential energy. Water at the top of waterfall. So you know, when I told you, when the object is at a certain height, what energy does it have? Potential energy. So water at the top of a waterfall, yo-yo being held in your hand when you change its position, and drawing of a bow. So when you stretch a bow, okay, when you stretch a bow, you're changing its position. Okay, and what energy does it gain? Potential energy. So these are the examples of potential energy. Now some of the examples of potential as well as kinetic. Potential, a car sitting in the driveway. Kinetic, a car driving down the street. Potential, a ball in a basketball player's hand. That means just holding it. Okay, he hasn't bounced it. A ball bouncing down the court. That means when you bounce the ball, which energy does it have? Kinetic energy. A sleeping child has potential energy, and the child, when jumping up in the bed, has kinetic energy. A log in a fireplace has potential energy, and when you burn that log, has kinetic energy, and the other energy is also related to it. We'll be discussing that later. A lamp which is not turned on has potential energy, and the lamp which is turned on has kinetic energy. So examples here, battery, these are examples of kinetic and potential. Now these are further examples of potential energy. See, the stone, this rock is at a certain height from the ground, so it has potential energy. Even the spring, when you compress it, okay, when you compress it up and down, it has potential energy because it changes position. The brick which is on the ground does not have potential energy, but when you lift this brick to a certain height, it gains potential energy. The expression for potential energy is mgh. M stands for mass, g stands for acceleration due to gravity, and h stands for height. And this is very important. This factor plays a very important role in changing the value of potential energy. And the value of G is fixed, that's 9.8. So these are the types of potential energy. It is categorized into three types. Gravitational potential energy, potential energy because of the gravitational pull of the earth. Gravitational potential energy. potential energy. So when you stretch a rubber band, okay, when you stretch a rubber band, what energy does it gain? It gains elastic potential energy. Not just rubber band like in case of bow, like in case of slingshot. Okay, and chemical potential energy is the energy which is used, you know, by the leaves when they undergo the process of photosynthesis. They liberate energy, isn't it? Which is energy which is between the atoms and molecules. So these are the different forms of potential energy. Like kinetic energy, potential energy also depends upon two factors. One is mass, the other is height. Okay, more the mass, more will be the potential energy, and more the height, more will be the potential energy. Now see here, there are two spheres here. One is at a more altitude than the yellow one. The blue is at more altitude than the yellow one. So which one will have more potential energy? It is the blue one. The blue one will have more potential energy than the yellow one because it is more height. That means more the height, more will be the potential energy. Now see here, they both are at the same height. Okay, in this case, they depend upon the mass. This one, the green one, has more gravitation, more potential energy because it has more mass. Okay, so more the mass, more will be the potential energy. So this is all we have. Okay, so this is all we have learned for today. And what I want you people to do is please go through your book, revise what we have learned, and if there's any doubt, please do ask. In the next class, we'll be doing the numericals and some other terms related to energy. Thank you.